Hi, this is Don Carson. In 2020, I was asked to do a series of lectures on theme park design subjects, and one of those lectures was on the use of 3D as part of the design process for creating themed environments. And this is that presentation. I'll just go through the various steps and some of the techniques that can be used when designing theme park attractions. But the first question worth asking is why use 3D at all? Aren't drawings enough? Absolutely, drawings is a surefire way to really quickly communicate a design to someone. But more and more, we're finding that integrating 3D into that process is helpful, not only to help you better understand your design, but also for you to better communicate to others. So when you think about what your job is as a sort of an effective designer, it's you want to be able to use whatever tool is best suited for the job of communicating your design to the various disciplines who will be responsible for making it a reality. So your job above and beyond being a designer or an artist is that your designs and art are responsible for communicating that design to those people who are in different disciplines than yours, who are going to make it real. And there's also a selfish reason, and that is the better you are at communicating that design, the more likely that the finished results look like you had intended. So grabbing for whatever tools you need to help communicate that is great, and one of those tools is definitely 3D. So the traditional way of communicating a concept was certainly through drawings, and Disneyland is a perfect example of a place that was designed by drawings. Even the drafting of the architectural plans was not done in a computer. So drawings can really communicate a concept and also sort of a sense of whimsy and style. But as a part of that design process, one could also build a sort of rudimentary version of it in 3D. And there's a lot of reasons why one would do that. One is it better helps you understand the scale of the thing that you're designing and whether that scale works. But also, the drawing can cheat a little bit and suggest that something will work in space in a way that you might find out later when you start thinking about it dimensionally, it may not. Also, when you're doing design in 3D, it allows you to show all sides of it. The 2D sketch can sometimes sort of suggest what's happening on the back end, but if it's a 3D object, you can actually turn it around and see what the back side looks like and how that relates to the front. And best of all is if you're designing things to scale, is that there's this extra bit of information that's buried in these models, and that is that you can actually take measurements off them. If this actually works for a person to interact with and it's going to fulfill what you need it to in your design, the ability to hand that model off to the architects, the show set designers, the engineers, so that even in the earliest phases of concept, they can kind of get information from your design because you've built a model. That's always, a great way to start. So let's say that you don't know how to use any 3D software, or you aren't necessarily all that terribly interested in becoming a 3D artist. My advice is you only need to understand and learn those functions that will allow you to communicate your design to your team and your client. And some of these 3D programs can be something that takes years and years for you to feel comfortable and adept at using. So approaching any new software so that you are only learning the thing you need to learn to communicate your design is fine. But at the very least, even if you're not going to necessarily jump into the world of designing and building things as 3D models, at least be familiar enough with the software that if someone gives you a model that you can open it, that you can navigate around in it, and potentially, especially if you're doing paintings, find a way to move the camera so that you can take a snapshot of the sort of the point of view that you like, and then you could use that to inform or use as an underdrawing for your illustration. So there's lots of software out there, and these are just a few of them, but the biggies are kind of in three categories. You've got sort of Maya, 3D Max, and Blender, and they're sort of the high-end industry standard used for everything. They have a very, very steep learning curve, and not always necessarily artist friendly. I think artists have learned to use these programs because they've needed to, more than whether or not they had been designed, joyfully for the act of art creation. Although I would say that Blender is probably much more artist friendly than the other options. But all three of them are standards, and there are people who've built entire careers learning how to use those and are very good at it. SketchUp and Rhino are what I call sort of napkin sketch versions of 3D. They can be used for very detailed models, but really they're a wonderful way to very quickly create sort of architectural spaces and try things out before you get into something that's higher poly that you might use in Maya, 3D Max, or Blender. And then the other end of it is sort of Revit and CAD, where you're actually using it to design, but you're also using it to document and communicate that design. So I'm going to mainly talk about SketchUp. It's the one that I use. I could just as easily have had Rhino be the tool that I used all the time. And there's a bunch of reasons why I use SketchUp. I do use Blender and 3D Max as well, but SketchUp is the place that I actually do most of my sort of concepting within. And so why SketchUp? One, it's kind of universally used. It's relatively inexpensive. It's not the price of some of those higher end ones, although Blender is actually free. It is designed for architects, so the models are to scale. So everything that you're building is with keeping in mind the fact that it's going to be built as something that human beings are going to interact with. And what can happen with the more artistic higher end software is that their units aren't necessarily feet and inches and meters. They're units that are relatable to the world that the software has created for you. So the fact that you're designing within something that is an architectural tool, especially as an environmental designer, is really handy to keep in mind at all times that you're building architectural models as part of your design process. It communicates with CAD really well, so even in your roughest models, you can export CAD files that you can hand to architectural team members and show set team members, and they'll be able to use it and integrate it into their CAD drawings. It has an established workflow for VR. There are a bunch of third-party tools that allow you to sort of plug and play your model and go from looking at it on your screen, on your computer, to putting a VR headset in and being able to wander around inside your design. And those are getting easier and easier and more ubiquitous as time goes on. And everything is potentially buildable because you're in a mindset of thinking about the dimensions being related to a person. It keeps you honest, and it makes sure that the thing that you're designing, is ultimate goal is to become a built place, a place for people to experience. And lastly, of all of the programs, it isn't evil, or at least not as much. And sometimes one wonders when you've got a large software company whether or not 100% of their focus is on the user. I would say an exception to that is certainly Blender, who is very, very dedicated to the tools that they're creating and the audience and the people who are using their product. And I feel that SketchUp's gone through a variety of iterations, and it's leaning more heavily toward a subscription model, which I think is a crime. But for the moment, it does still have a free web-based version of itself, so you can easily jump in and learn these tools without having to put money down right away. So the traditional way that models were created is if you had a drawing, a plan drawing, anything that involved what the layout was on the ground for a design, you would turn it at a 45-degree angle, and then you'd create an orthographic view, which is basically you're just taking a ruler and you're drawing lines up from it. and then you're interpreting where the roof lines and the heights are based on that. So you could easily end up with a 3D sketch to your right, which is an orthographic view. So there's no, you could probably measure off of it, but you are basing it on a plan view. And that works just great. That's the way that I've done bird's eyes for decades. It communicates a bird's eye really nicely, but it does have a little bit of a flat view. You know, there's no sort of two-point perspective that gives you the feeling that you could dive into these spaces. So an alternative is to do the same drawing, is to build a rudimentary model as an aid for your drawing that you could use as an underdrawing. The advantage to that is as you're building this rudimentary model, you're thinking about things like the height of the floors, or the height of the and width of the doors, or the height of the tower, that even though the drawing on the right looks very much like the previous orthographic version, there's built into it more information because you've thought about that bit of information a little bit more because you've had to actually build it in 3D. Both are acceptable ways to communicate, especially if your design is going to be seen as a drawing only. But if you potentially could use the model on the left as part of your project, or maybe be a part of a larger master model, that's a benefit as well. So even though there have been projects where I've been asked mainly just to produce a bird's eye illustration, and this is really all that they've asked me to design, I'll often do a rudimentary, very, very simple low poly model of the place so that I can get a camera view that I like for the bird's eye, and then I just use this as an drawing, and I'll do the drawing on top of it. The advantage is that now I have two documents. I have my pen and ink color illustration, and I have this model. So this model allows me to dive into the space as well as look at it from a bird's eye perspective. And that's another thing worth talking about too, is you might find you're working on a project where a lot of time up front is spent in plan view. A lot of iteration and versions and conversations are happening about what it looks like sort of from space, looking at it as a plan or a map. And there's a tremendous advantage even in the early stage of start building these rudimentary spaces so that you don't get lost in convincing yourself that it's going to work based only by plans, but you actually are thinking all the time about what it's like to get down on the ground and feel what it's like to be in these spaces. So the advantage to these sort of super, super quick low poly models is you start to get an idea of how all these pieces feel if you were to walk around in this environment when it was completed. And it also acts as a perfect backdrop for you to do sketches over the top of. So your sketches become informed because you understand that this is actually something that could fit in the venue where this finished design is going to ultimately live. So whether or not you're building a model that informs a drawing, or you're building a drawing that informs a model, both are of value. And sometimes both are created, and maybe the drawing goes to the presentation, but the model can be exported as CAD or be used for 3D printing or be used for a larger model. So we're blurring the lines between what we're going to be using to communicate the design, not to take anything away from the charm and the sort of magic of a really nice sketch, but to know that that sketch is something that could actually be built and have the proof in a 3D model is extremely valuable, not only to you as a designer, but the project at large. So when do you start jumping in and start doing models? And my belief is you start in probably the first day. This is a project I sort of played around with in early 2020, this idea of doing a faux ride based upon Game of Thrones and of Winterfell, the attack on Winterfell. And so I just started out just laying out in a bubble diagram this sort of, there's nothing the scale about this drawing, it's just an idea where the queue is, where the ride vehicles were going to go, what scenes they went through, what the spacing was, for those vehicles. And I just took this really rough scaleless drawing and I brought it into SketchUp and I just extruded a path to follow my loosely hand-drawn version. And I also created a vehicle that I thought could have 6 people sitting in it. And so I scaled the entire thing to accommodate a vehicle that held 6 people. And all of a sudden I'm starting to get a scale, even though I didn't start out with one when I was doing my rough drawing. And now that I have a track, I can actually extrude those walls that I just indicated in my sketch. So I'm starting to get an idea of height, and I'm starting to bring in various elements. Some of them I'm building and some of them I found that I can start populating the model with to get a better idea of what could fit in this space. And at this point, I'm still in really, really early concept. We haven't talked about size of show buildings or anything. We're just seeing whether or not a ride like this would be fun. And best of all is that although it's really valuable for me to be able to look at it as a model, I also can get down inside of it and start to see about the composition of the scenes and whether or not, from the point of view of the rider in the vehicle, what the experience would be like. Even though there's no color or anything, I'm starting to get an idea of the massing of the spaces in the scenes as you're moving from one to the next. And I could take that so far as to actually add props and stand-ins for figures to see whether or not this really, really rough sketch that I had done is starting to feel like an attraction that would work. So this idea of building a rough model as part of that design process, and sometimes the first thing you do is not only is it going to inform the illustration later, but something else that happens in a project is that inevitably, seemingly way earlier than you'd like, an estimator is going to want to sit down with you and they're going to ask very specific questions about things that you may not have thought of yet. Like in your fast food restaurant, how many prop barrels are there going to be? And if you haven't thought about that, or there hasn't been time to think about that, then it's hard to answer it. So they're going to make assumptions based upon a guess, their own or yours. But if you've built a rudimentary model, you could actually point and count out how many barrels will fit in the space or where you might use it. And best of all, this model also allows you to bring the camera in, find a nice location, and then you can render on top of it a drawing that gives more of a feeling for how the thing would look when it was completed. But it's all based upon the fact that you know that all of these will fit within the space. And it's starting to feel as you had imagined the space would look and feel, while still helping the architects, the engineers, and the estimator understand how much it's going to cost and how it's going to be constructed. So one thing to keep in mind when you're doing models, especially with something like SketchUp or Rhino, is that everything is related to the size of a human being. So whether it's the width of the height of a door or the stair tread or a ramp, there are rules and there are ways in which humans interact with space. So while you're designing, even early on, even if you don't have the specs for a ride vehicle from a vendor yet and aren't quite sure what you're going to be ultimately designing, you can be pretty sure that whatever you're designing is going to be relative to the scale of a human being. So building your things around basically where someone's rear end and fits and their knees go and their feet land is a good way to start. So making sort of educated guesses as to what your ride vehicle might be like based upon how many people could comfortably sit in it is a way in which to start your design. Later on, you'll be sitting down with ride engineers and people who will help you design, or vendors will help you design what that final ride system is going to be. But that shouldn't start you from, at the very least, starting to get an idea through the use of 3D models. Another thing that's important is that although this software is capable of doing beautiful high poly models, I really stress the importance of building low poly models to begin with for a bunch of reasons. And I think my drum beating about Low polys comes from having been in the computer game industry in the mid to late 90s, where 3D was just becoming a thing, and we were really, really forced to keep our models as low poly as possible, mainly because they needed to be able to run on anybody's computer. And in our case, when we're designing themed environments, we're often designing places that's filled with tens of thousands of objects. And if you're not thinking low poly as you're starting to build those objects, they add up really fast. And before you know it, all of a sudden you have a model that's a couple of gigs in size, and it takes time to even to open, let alone to navigate around. So when I'm making low poly objects, I often will save off a lot of the object into sort of a warehouse personal file of things that I could repeatedly use over different projects, whether they're light fixtures or retail furniture fixtures, or even the railing for queues. So high poly is something that's going to be in your life, and especially when you're dealing with a vendor who is responsible for delivering one specific thing. Often because they only design the one thing, they want their objects to be as perfect as possible. And also a lot of the models that you're receiving are actually the same models that they're using for fabricators to actually fabricate from. So someone might give you a model of like this flume, and it looks lovely, but boy, when you get down to using it, the number of polys that are used in here makes your models incredibly bloated and hard to navigate. So whenever possible, even when given these models, I highly recommend doing your own very low poly version of it. And a way to describe sort of slippery slope of high poly is that the desire to create something that has smooth transitions or curves means that you have to put a lot of polys in it. But if you are to really lean heavily on the ability for your software to shade even low poly things, you can get an effect that looks good enough with a lot less poly. So as an example, these supports for railing on a staircase, you might want them to look really nice, but when you factor in how many of them are going to be on this staircase, and then you multiply how many staircases are in your structure, all of a sudden your model is many, many gigs bigger than it needs to be, purely because you've desired this a level of detail in something as simple as the rungs that support the railing on your staircases. So in this example on the right, you can see one version of the cylinder is 314 polys, and the other is 23 polys. And if you look at both of those shapes, although you can see the telltale facets at the top and the bottom on the lower right version, to the eye when you're looking at it with the smoothing groups turned on, it looks the same. And you end up with a model that's much easier to navigate. Another thing to keep in mind too is that you can also use flats, especially during concept design. Flats are a way to represent things with lots more detail that will be later replaced with higher poly versions of these characters or set pieces. And you can end up with renders that are really evocative, that feel like you're in the attraction, but the models are incredibly low poly and accessible. My rule is that I would love my concept model as long as it possibly can to be something that could be emailed back and forth between team members. As soon as you get over 40 megs and then you start getting up into the hundreds, you start to end up with having files that take time to upload and download, take time to open, take time to navigate, take time to render. The lower poly that you can stick with, the better. And the fact that you can bring in these PNG cutouts or JPEG flats and start to get a real feel for what an attraction is going to look like before you get into the need to have them be full of high polys, the better. Another thing that you can do without even necessarily dealing with a 3D design package, but you are familiar with Adobe After Effects, is by taking your Photoshop layers and then layering them in 3D within After Effects. You can communicate a design in 3 dimensions while retaining sort of low poly flats as where the files are living. as opposed to super high poly ones. So there is definitely a place for high poly and high resolution models, absolutely. When you start getting out of the concept phase and you start going into the schematic and design development stages, these models are going to have to communicate a lot of information to vendors and those people who are going to be responsible for building that. And they're going to want as much detail as possible. So at some point, it's going to make sense as you're going to want to take your low poly placeholder models and replace them with higher poly versions of the characters or props, because those are just going to help make sure that the thing that you're designing is actually being interpreted by the vendor and is usable. A lot of these files could be 3D printed or CNC'd and be a real foundation for the finished design. You're also going to inherit models that are Revit models or CAD models that were designed in an environment that isn't necessarily taking into consideration or doesn't really care about how many polys they're using. So something as simple as a glass surface could be shattered into tens of thousands or hundreds of thousands of polys that are easy to navigate in CAD or Revit, but once they come into something like SketchUp, they really bog down or fracture the model. So whenever possible, when you do inherit these higher poly models, is to replace them by taking the time to rebuild some of these in lower polys and then completely delete and purge your model of their originals. You don't need them to be this high poly on a daily basis for art direction purposes, and it's going to make your life so much easier if you're not always fighting with the model because it's just become so huge and bloated just because you have kept and held on to things that you've inherited. And that's true of the SketchUp 3D Warehouse, which is a wonderful resource for downloading models that other people have built. And I use it myself all the time, mostly to discover equivalence. So let's say that I'm building a park and I just want to, in my brain, understand its scale related to something I'm familiar with. So I might go download some fan has recreated Sleeping Beauty castles from Disneyland. I can grab that model and I can drop it into my model and get a really quick idea of the scale of my project in relation to something that I'm familiar with, like Disneyland, and then I can delete that model. And if I'm pulling information like doorways or equipment or even the Eiffel Tower, let's say that my project has the Eiffel Tower in it, I could easily find that here in the 3D warehouse, but because I wasn't the person who built it and I don't know how economical that model is, there's some chances that when I bring that in, I'm actually bringing in something that could break my model. So what I'll do is I'll bring it in, I will get it in there, make sure it's to scale, and then I'll build my low poly version of that model, and then I delete the 3D warehouse version. So incredibly valuable, but also important to replace it as quickly as possible with something that you have control over. So texturing your models is super helpful too, especially as we're starting to get tools that allow us to do real-time rendering of our models that look amazingly like they're finished. So if you have the luxury of time to texture your models, then I highly recommend that as well. There are some rules to keep in mind when you're texturing. Textures tend to draw attention to themselves if there's a lot of contrast in them. So you might find that doing textures that are actually relatively sort of in a value range that's kind of similar to itself and a little bland, in the end, because it's working with so many other textures, will make your finished product look good. So this is an example of a SketchUp model that has just had textures applied to it. And textures can be found on the internet, although sadly more and more the first 100 or 200 or 300 of textures that are available for you are for sale and not something you just can grab. So when you do find textures that are free or that you purchase, start creating your own sort of library of those textures, because you're going to use bricks and stucco and concrete and things like that all the time for the length of your career. So building up a library of those textures is valuable. It's also important to keep in mind that textures are one of the things that will bloat your model even faster than polygons if you're not careful. I've seen models where people have brought in, 3,000 by 3,000, pixel textures that are going to be applied to a doorknob that are in a PDF. And so all of a sudden your model turns in from a 100 meg model to a 800 meg model, and a lot of that is because of the textures you're starting to apply to it. So keep in mind that texture scale is relatable to the size of the avatar. So a texture that's going on a doorknob does not need to be that big. In fact, if it's that detailed, it's actually going to stand out as being kind of odd that there's so much detail on the doorknob, but the wall next to it feels really kind of low res in comparison. So as a sort of a rule of thumb, and this is something that the game industry is very familiar with, is figure out what the dimensions of your texture are in relationship to the size of a person. So this was more restrictive when computers weren't as powerful as they are right now, but I think it's probably safe to say that if you have a texture that's applied to a wall, that a 512 by 512 pixel texture is about the size of a person. And if you do that, you're just not going to be able to tell that it is that it's a digital image unless you get super close to it, as relatable to the entire area. So if you're going to do a giant mural behind the thing, then that could be a huge texture with lots and lots of detail and higher pixel size. But if it's going to be on simple things like a rock that repeats is very small, or especially tileable textures, think of them as being about the size in relationship to the viewer or the avatar that's going to be in those spaces. The other advantage to 3D models is that you can also use them to print from. There was a time where getting something from your computer and getting a 3D print of it was many steps, a lot of sort of trying to find out why it's broken and why it's not printing. But that's just not true anymore. That even models that are very quickly thrown together can be interpolated and fixed very rapidly and printed as prototypes. Another advantage to 3D is we're starting to be able to experience our designs first person, to walk around inside the design while we're designing it. And best of all, we're starting to be able to actually meet colleagues and friends and clients inside the models, no matter how early in the process that design is in. So more and more you're going to see virtual reality as one of the ways that you consume the 3D assets you're creating, whether it's objects or places. And so when is the right time to build a model? My philosophy is, build it right away. If someone was to ask me to design a theater set, the very first thing I would do is I would build the 3D theater before I did anything else. Because I know that the value of having that theater is going to inform to me as a designer what that set's going to look like from anywhere in the house of the theater building, which will help me as a designer, but also help the choreographer and the lighting person and the investors understand what the finished set is going to look like in the context of the place it's going to be seen. And I would also say the same is true of when before you've even laid out anything to scale, take a bubble diagram, a very simple rough sketch that's done during a brainstorming meeting, throw some relative scale on it in relationship to the size of the person or the avatar, and then get that in the model so you can start to feel what the scale of your project is before you even start imagining where the walls are. And best of all with VR is that you can also have a meeting standing on top of this rough bubble diagram and really get an idea of its scale before you even go through the process of figuring out where the walls are and how high they are. So why VR? We're placemakers, and our ultimate product is to create things that are consumed by humans in the physical world. Although more and more, I would argue that we have the potential of creating some of these in a virtual world that's consumed digitally and not necessarily physically only. But since most of our stuff is going to be physical, we want to be able to visit our work while we're designing it. So being able to check on your design by going inside of it several times during the process of its design is extremely helpful. Also, you can see it over time so that you could come in with your rough sort of pen and ink pencil sketch, get everything to the right scale to make sure it works, and then replace those pieces with color pieces, all the while revisiting it to make sure that not only are the scales and the relationship and locations of these pieces working, but how they work together when they're done in color. Some of the advantages to VR is that you can make regular virtual site visits. This is where you personally sort of bring your camera with you and record your experience walking through a place, even early on in the pencil form, like basically giving people a tour of your model. The advantage to being able to record it is that for those people that either don't have a headset or don't have an easy way to jump in there with you, you can share the experience by recording it and annotating it by pointing things out as you wander through it. It also helps you discover problems really, really quickly because you're relating to it as a person. So the ability to discover problems that may not have occurred to you until you were in the field during construction is incredibly valuable, so that when you do finally get to the field and start building it, you've already worked a lot of these scale issues out because you've already walked the site dozens and dozens of times prior to them even starting construction. And models are also very, very good for figuring out whether or not you don't necessarily need set pieces to do a lot of the work. Blacklight is a perfect example of, especially in the Disney blacklight attractions, that a lot of depth can be suggested in paint that doesn't necessarily need to be dimensional. And one of the ways to check that is through VR, being able to wander through it and see whether or not a lot of the stuff that you thought was going to have to be physical could actually be represented as two-dimensional or at least cut out elements. What's happening too a lot right now is that clients are increasingly asking before they'll buy off on a design, to be able to consume it and see it in VR. So I think as designers, we're going to have put upon us ability to present in virtual reality as well as the traditional ways we have, which is through 2D images and videos. So keeping in mind that if you're designing with VR in mind, it becomes very easy for the client to be able to step in and be a part of and experience the design in its various phases, because either they have a local VR headset that they can just plug into, or they come to your office or and use yours. So, but you might say VR is expensive, and it has been in the past, but the prices are going down all the time. We now have the Oculus Quest, which is a reasonably priced headset and is becoming kind of the standard one that a lot of developers of software are starting to accommodate when they're working on projects. It said it works like pretty streamlined with both SketchUp and Revit, and because you're designing architecturally and to this relative scale to a human, you can jump into these models and you can experience them the way they were intended to be experienced, which is based on the height of you as a person. So it's getting easier and easier for you to experience your designs, even in the early phases in VR. And currently for like the real-time rendering, super realistic VR experiences, those still need you to be tethered to a powerful PC, but that's not for long. I think that as these standalone mobile VR headsets become more powerful and we figure out ways to real-time render in them, a lot of the experiences that are currently something you have to experience and attached to a PC is not going to be true for long. Enscape is a wonderful tool that I use. It's actually it's software that is like an extension for SketchUp that allows you to experience your models as fully rendered real-time environments with real-time lighting. So this is that same SketchUp model, but moving around it in Enscape. Advantage to Enscape 2 is not only can you render this off, but you can also put on the headset and wander around at this resolution and see what your design is looking like, fully textured and lit. And so as far as sculpting, there are now alternatives like Gravity Sketch that allow you to sculpt while in VR, which I think is incredibly intuitive and a very, very fast way to not only create rudimentary models, low poly models, but also high poly models that are as high as anything that you would create in the higher end, more expensive pieces of software. And they're instantly 3D printable as well. So keep an eye on Gravity Sketch, which is free now and is available for the tethered PC headsets, but also the Oculus Quest works really well on that as well. And so I think that probably Gravity Sketch is going to be one of those tools that becomes as ubiquitous as Photoshop when it comes to a tool to allow you to design in VR objects that are 3D. Also, it's interesting that Gravity Sketch, as powerful as it is, its founders really think of it as an industrial design tool. So if you go to their website and look at examples of what people are using to build their 3D models, a lot of them are either race cars or fancy designer shoes. The fact that you can also use it to create elephants in smoking jackets is something that I don't think the founders thought about, but it doesn't make it any more or less powerful. So in the end, you can take that model that you've built in Gravity Sketch, bring it to a 3D printer, and print it in 3D fairly easily. And then sort of in the beta world right now, Facebook is beta testing by invitation only at the moment, a place called Horizon, which is meant to be an online community where you're represented by an avatar that then has creation tools that allow you to build things and share it with others. And so I've been playing around in it and doing what is basically environmental sketches, but it has the ability to add lighting, sound effects, and particle effects to it. And although the shapes that you're given to work with are all primitive shapes, and it doesn't allow for a lot of editing other than scale changes and color changes and surface treatments, I've had a lot of luck creating very evocative, dramatic, and theme park-like environments inside of it just as tests. And best of all, I can actually bring friends in with me who are part of the beta. And even better, we can work together and actually create these models together within the application. So side by side, we can actually build these environments. And I've already had some amazing experiences with friends as we've been building virtual environments, lighting them, adding music, adding sound effects, and adding particle effects to them while we have a conversation while we're doing it. So keep your eyes on Horizon. It does have one major con, and that is that it is not exportable. So it's definitely not something that I would use as for generating something that would eventually be used as a model for theme park design. But as far as getting a feel very, very quickly for the size of a space and also the drama of lighting and the juxtaposition of the sizes of objects and shapes, it's something that I'd love to see more applications start to offer. Not only the ability to build 3D environments, but the ability to affect the mood and the lighting through light designs and effects and audio. So, and like I said, best of all, you can share the experience with your friends and build things together. So, and then lastly, there's Unity and Unreal, which allows you to bring the models that you've created and add all of the animations and effects that you are planning for your finished attraction. And the one drawback to both Unity and Unreal is they are game engines created by the game industry. So you do have to think a little bit like a game designer to get them to work. But as I've said, you only need to learn those tools that you need to learn to just do the things you need. So being able to create a vehicle that moves along a spline, being able to attach a camera, being able to animate doors and effects, and to be able to export it out to be consumed by others is more than enough. And it's all learnable on the internet. So as a conclusion, along with traditional methods of drawing and painting, integrating 3D tools into your design process is going to make you a better communicator. And it's also marvelous for you selfishly as a designer to prove that your designs will work once they're constructed. So that's it. I know that technology is rapidly moving. New tools are coming out almost on a weekly basis. So be adventurous. Don't define yourself by any one piece of software, and be willing to try things out, because I have a feeling that 3D is now an integrated part of the work that we do that will not replace 2D drawings, but enhance them. So thank you very much.